Using exponential form of complex numbers in finding the power still uses a specific rule in the laws of exponents. Learn about it here in Mathematics of Engineering. The exponential form of a complex number is notated as z as equal to the modulus r times e raised to I times the argument theta. If we raise z into the power of n, the whole expression will be raised to n, where n can be distributed among the terms, making z raised to n as r raised to n times e raised to I theta times n. In the laws of exponents, this part is what is known as power of the power rule, where it states that e raised to m and again raised to n can be written as the base e raised to m multiplied by n. Therefore, z raised to n is simply r raised to n times e raised to I times n theta. Say we are to take the ninth power of the complex number 3 plus I. Since the exponential form is based on the modulus and argument, we should identify these parameters first. But before that, we graph the vector. Positive 3 points to the right, and I points upwards, so the vector lies in the first quadrant. The modulus is solved as the root of a squared plus b squared, that is, 3 squared plus 1 squared, which becomes the root of 10. Theta, on the other hand, is the inverse tangent of b over a, that is 1 over 3, which gives 0.3218 radians. Note that exponential form works in radians, so solutions should be in that unit. Now, with the standard for z raised to n, we plug the modulus and argument to have the root of 10 raised to 9 times e raised to y times 0.3218 raised to 9. Let's simplify each part. The root of 10 raised to 9 can be written as the root of 10 raised to 8 with the root of 10. In rational exponents, we can write 10 raised to 8 over 2 times the root of 10. 8 halves is 4, so the modulus is 10 raised to 4 times the root of 10. For the second part, e raised to y multiplied by 9 times 0.3218 is simplified as e raised to 2.8962i. Place these two in the format and get z raised to 9 as 10,000 root of 10 times e raised to 2.8962i. For the next example, we are to take the 8th power of 1 minus 2y. If we draw the complex number, we have positive 1 pointing to the right and negative 2y is a component pointing downwards. The vector then lies in the fourth quadrant. The modulus is solved as the root of 1 squared plus negative 2 squared to have the root of 5. The argument is the inverse tangent of negative 2 over 1, which gives negative 1.1071 radians. To make this positive, take its revolutionary counterpart, and that is 5.1761. Following the exponential form, z raised to 8 is the root of 5 raised to 8 times e raised to y times 5.1761 raised to 8. For the modulus, root of 5 raised to 8 can be written as 5 raised to 8 halves, or that is 5 raised to 4, which can be simplified as 625. The other part is e raised to y times 8 by 5.1761, which becomes e raised to 41.4088i. Thus, z raised to 8 is 625 times e raised to 41.4088i. Next is to determine the sixth power of the root of 4 plus the root of 2 times I. This can be written as 2 plus root of 2 times I raised to 6. Illustrating positive 2 and positive 2y, the vector turns out to be located in the first quadrant. The modulus is taken as root of 2 squared plus the square of root of 2, which makes root of 6. Theta is the inverse tangent of root of 2 over 2, which is 0.6155. Place these figures into the format and get z raised to 6 as equal to the root of 6 raised to 6 times e raised to y times 0.6155 raised to 6. The modulus, root of 6 raised to 6, is also written as 6 raised to 6 halves, which makes 6 cubed, or that is 216. E raised to y times 6 multiplied by 0.6155 also becomes e raised to 3.693i. The complex power z raised to 8 is then 216 times e raised to 3.693i. The succeeding example looks for the 12th power of the complex number, negative root of 5 minus 4i. Illustrating this in the Cartesian plane, the vector lies in the third quadrant. R is then solved as the root of the square of negative root of 5 plus the square of negative 4. That would be the root of 21. Theta is then the inverse tangent of negative 4 over negative root of 5, which comes out as 1.0611. Draw this in the Cartesian plane and find out that 1.0611 draws a vector on the first quadrant. This is opposite the vector we are concerned with. Add pi to coincide with the vector in the third quadrant, and take theta as 4.2026. Place the modulus and theta in the format, and get z raised to 6 as the root of 21 raised to 12 times e raised to y times 4.2026 raised to 12. The root of 21 raised to 12 is like 21 raised to 12 halves, which is then taken as 21 raised to 6. The other part is e raised to y times 12 by 4.2026, which is simplified as e raised to 50.4318i. So z raised to 12 is 21 raised to 6 times e raised to 50.4318i.